with me, Simon Prickett.
Right in the corner. Ah!
Oh, hi there YouTube. My name's Simon Prickett with Redis, and this is a game that I wrote with the Kaboom.js framework, Redis, and Express and Node.js. We're going to check out how it works in this video, but first, let's explain the gameplay. So, my player here is stuck in a maze, and they need to escape. And in order to escape from the maze, they need to find 3 keys. So here's a key right here. We just found one. We got it. And we can move around. These green doors here are unlocked, so I can move through those freely without holding any keys. If I find a flag, then what that's going to do is it's going to teleport me to a random other room. So I get to move around the maze potentially more quickly, or I might get set back. And if I find another type of door, what we'll see here is that, let's find a room with one of these in. There should be a red door somewhere. And of course, we're not seeing one immediately, but there will be one if we keep moving around. Here we go. So a red door is a locked door, and I need to have a certain number of keys to pass through it. So in this case, I had the right number of keys, just the one, and I was able to go through. And in other cases, I'm going to be locked out until I have enough keys. So the aim of the game here is to collect 3 keys. And once I've got 3 keys, I will be allowed to exit from the door in the room that I started in, which is coming up right now. So I started here, and as you can see, not allowed to leave yet because I don't have enough keys. So the aim of the game is collect all of the keys, escape from the maze, and how we're going to use Redis in this game, what's a key value data store got to do with gaming, is a couple of things. We are storing the game map here, so all of the layouts of these rooms and what tiles belong in them in Redis, and we're using the RedisJSON module for that. And then every time I move around between a room here, I'm storing an event in a Redis stream, and we're going to use those events to calculate how long my game took and how many moves I took to complete it. So let's dig in and take a look at how this works. Okay, so the code for this project's in a public repo on GitHub here in the Redis developer organization, which is a great place to find example code that uses Redis. So what I'm going to do now is really quickly git clone this. So switch to the terminal here, git clone the repo. And once we've done that, we're going to go into Redis Kaboom RPG and take a look at what we got. So we have a couple of things here. There's a Docker Compose YAML that's going to give us a Redis instance with the RedisJSON module that we need for this project. And there's a package.json that's going to describe the scripts to run the project in Node.js and also the dependencies that we need, which will be the IO-Redis Redis client, the Express framework for Node.js. Okay, so I need to do a couple of things here. First off, let's install my dependencies, so npm install. All done, and let's start Redis. So docker compose up -d to run it in the background, so we get the command line back here. So it's starting Redis in the background. Off it goes, and it's done. So what we then need to do is load the game's data into Redis. So the game data at this point consists of the map of rooms that we want to navigate around. Those are a JSON file. It's called gamemap.json here, and we'll look at how that works and how it gets loaded into Redis. But for now, let's just go ahead and load it. So I can do npm run load. Okay, that loaded. I can now start the game server with npm run dev. This will start an express process that will listen on 8080. So that's up and running. Now back to the browser here. And I should be able to go to localhost 8080. And there we go. So we have our game ready to go. So I can hit space to begin. I can start running around this map. And it looks like everything's working. So in this game, the map data here that we see is coming from Redis. And the front end here is rendered using something called Kaboom.js, which is a game framework. And the front end talks to the back end using an Express application. So we're going to look at all of those things in turn, but first we'll take a look at how the map's represented in Redis. Before going any further, let's check out how Redis has actually stored this and how we can visualize it in Redis. I'm using the Redis Insight tool for this. It's a great free tool for looking at what's inside your Redis instances, managing their health, and it understands some of the Redis modules, including JSON. So here in the key browser, we can see I have a single key in this instance right now. It's called Kaboom::rooms, so the one that our data loader created. And it's of type RedJSON-RL, so it's a Redis JSON key. And what's in here is kind of what we'd expect. It's basically a representation of the JSON document that we loaded. So the room in position 0 has got a layout, and it's got doors, and it's got everything that we had in that data file. So I can see where those doors lead to, and this one is the one that requires keys. And layout here is an array with all of the characters needed to build the room when the front end renders it. So the great thing about Redis JSON is I can get the value of this key in its entirety, or I can get parts of it. And that's exactly what we want for this game. So I don't want to get all 31 rooms every single time the user enters a room. I just want to be able to get the room that they've entered. So imagine they're going to room ID 2. I could do something like this. I could say json.get kaboom rooms, and then I want the thing at array position 2. So this is a JSON path syntax. And when I ask it for the thing at array position 2, I get only that room back. So the database has done this work for us. We don't have to pull that whole document out, parse it, remove everything else that we want, and send it back to our front end. We can, in our API server, just do this simple query and get exactly the data that we want. And we'll go on and look at how that works in the Express application later. But next, we'll check out how maps work in the front end. Okay, let's take a look at how this JSON data that we've loaded into Redis actually gets rendered as a tile map in Kaboom in the front end here. So in Kaboom, everything is what's called a scene. So a scene is equivalent to a screen in a game. So here we've got the start scene showing for this game, and it's rendering in a canvas. So Kaboom renders everything in a canvas element. And when I press space, there was an event happen there in that scene, and I have event handler code that handles it and moves us to another scene. So the scene it's moved us to now is the main one for the game, which is called the play scene. And what that does is it expects a parameter of a room ID, so which room to render. And it will go to the Express backend and ask for that room's layout and other information. The backend will get that from Redis JSON. It will perform a little bit of work on it that we'll talk about later with regards to keys. And it will then send it back to the front end. And the front end then renders it. So here we can see this room looks like this. And when I walk into another room, we basically make another scene change from the play scene for room 0 to the play scene for room 1. And because it's parameterized, it's actually the same scene code that runs. It just goes and gets a different layout, renders it, and then it knows how to deal with all the key events like up, down, left, right, and what happens if the player crashes into certain things. We'll look at that again shortly. So what's happening here is we have a scene, and as we move around, that scene updates with a new map, go back to the server, get the data. So check out some code for that. So the JavaScript for the front end, the game itself, is in the static/JS folder in public. It's just a static file that Express serves. And there's some Kaboom specific stuff here, but in short, we initialize Kaboom, which is a library, and we tell it which canvas element in the HTML it's going to take over and render itself in, and some information about that. We have to load some sprites, so some graphics for the game, and we give them names. So these are just PNG images. I use ones that came with the Kaboom framework, and we can refer to those sprites later when rendering things. Then each room or each screen is a scene. So scene is a function in Kaboom, and we're saying here's a scene called play, and it takes a room number parameter, and here's a function that describes this scene or runs when this scene is selected. It's an async function in this case because we're going to make a call to Redis. That's a network call, so we have to be an async function because we're going to use await. So whenever this scene needs to be rendered, the first thing we do is we go off to the back end, which in turn talks to Redis. And we say, hey, get me the room for this game ID. and this room number. So for this specific game that we've started, get me the room number 0 or 1 or whatever it is. And we get a JSON document back for that. That JSON document looks pretty much like what we had in the JSON file. So in the game map here, it's going to contain layout and information about the doors. And then the front end is going to use that to build the tile map. So there's some preamble here about showing messages when the user hits certain things and dealing with key presses. We'll not look at those here. If you want to check those out, I'd suggest studying the code in GitHub. So the interesting thing here is how we render this room. So the room layout was an array of characters. If we look at this one here, we have like these equals characters and a 1 and a K and an @ symbol and an F. And we have to map each of those to sprites in Kaboom. So the equals, I was saying, were stone walls. The numbers are doors. The @ is the player. The K is the key, if the key is in that room. And F is the flag, the teleporter. So here we have a Kaboom specific configuration object where for each character, so here's the player, we say which sprite to use. And again, we give it a virtual name we can use later. And in some cases, we need to set other properties. So here we have the wall sprite with the equals, and we want the walls to be solid. So if the player walks into them, they can't go any further. So we don't have to write code for that. Kaboom's got us for that. We also want things like the key to be solid, and we want the flag to be solid and to use specific sprites. So each of these mapped PNG images, they get rendered whenever it sees these characters in the map. Now, the doors are slightly different. We have different types of door. So doors can be locked or unlocked types of doors. Unlocked doors are green, locked doors are red, and red doors, they have to have the right number of keys to go through. So we're going to look at the door information that we got back from the back end. So here we can look at the door. This one leads to another room, doesn't have any other information, so it's an unlocked door. This one leads to the special room or the end of the game, and it does require 3 keys, so it's a locked door. So what we're going to do is loop over all of the doors that we got back, so everything in that doors object that the backend gave us back out of Redis. And we are then going to have a look if it requires keys. We're going to render the locked door sprite, which will be the red door. And if it doesn't, we're going to render it as a green door. And then against this sprite in the tile map, Kaboom allows us to store additional data. So we're going to store where the door leads to, how many keys are required, and is it the end of the game door. And all of this information we'll use in like a collision detector for when the player touches the door and then something runs and we can determine what to do. So all of this stuff, rendering the layout, is handled for us by this amazingly good library function that we don't have to write called add level. So it understands this layout map of an array of characters, and it understands the room conf object, how to treat each character. And it's just going to render that in the canvas for us, which is great. So all of this is just done by that one function for us. We don't need to worry about that. So what we do need to worry about are some events. So we'll just gloss over how the player moves at the minute, and we'll look at, for example, what to do when the player touches a door. Again, Kaboom's a nice high-level framework. So what happens is we had a player sprite that we call player. So when the player dot overlaps something that has the sprite name door, then D is going to be the object for that door. And we can ask some questions of D and determine what to do. So I've got a short wait in here, which is like a Kaboom's version of a set timeout, so that the player touches the door. And then there's just a tiny wait before we do anything, so that it just gives a better experience. And we're then basically going to see if this door requires keys and the player has enough keys or doesn't have enough keys, then we're going to pop up a message saying, you need more keys to exit or to go through this door. Then Kaboom's got this fun method here called cam shake that's going to shake the camera. So it kind of looks like a no, you can't go through. So if I if I do this, if I go back to a room that has a locked door that I don't have enough keys for, so I'm holding 0 keys. If I go there, you'll see it says I need 3 more keys. So that's that event handler running because the player object has overlapped the door object. And then if the door is the end one and they did have enough keys for it, then we load a scene called winner, which will display the player's stats for the game. Otherwise, we just load the play scene again, so another room with and pass it in the room ID of whatever room that leads to, and this whole process starts again. So we then go to up here and start again with, where are we? The play scene for whatever room is the new room to render, and we run all of this over again. So what else happens when what happens when we do this, when we go fetch the data for this room? Is we'll need to look in server.js here. And where did I put it? It's in the source folder. There we go. So in server.js here, we need to go to the right route. Here we go. So what happens when we get the room for a specific game is we do some stuff with streams that we'll cover later what that is. And the meat of this is what we really do is use JSON.get to get the room numbers information. So if we want room 2, we need the third, because it's 0, 1, 2, 0 indexed. We need array index 2 in the Kaboom rooms JSON key. So what this does is we're using RedisJSON, JSON.get, the key name, and then 2. We'll just return the bit of the map that we need for this room and nothing more. We also check if the room has a key in it for this game, and we'll look at how that's determined later, but we're using a Redis set, and we basically say, hey, if this room ID is in the set of rooms that have keys for this specific game, then we have a key, and we're going to keep the key in the map. Otherwise, we're going to remove the K character from the map. So every room has a key position in it where the key would appear if the key was going to be in that room for this game. And we remove it in the case where it's not. And we'll look at how we determine where keys are in rooms for a given game shortly. And once we have all of that information and we've potentially slightly modified the layout, we return that back to the front end. And the front end here gets that, and then it basically just, as we saw, renders out the room conf information for each door, and the layout here is just passed straight into add level, at which point it's rendered. So Kaboom makes it very, very easy to render these things, and we're storing the map on the server, so the front end never has to retrieve the entire map. So you can't do any front-end hacking of JavaScript and see where the keys are hidden. And also the map could get really, really big, and we don't have to store that in the front end in memory. We can keep it on the server and just feed it to the front end as it needs rooms. Remember that the object of this game is to collect all of the keys and then escape through the door in the room that you started in. So the special exit door that requires 3 keys. So here we're looking at the layout for room 0. And we can see it has this door number 2, and door number 2 here is the special door that is the end door that requires 3 keys. Now, how do we put the keys in the game map? One way we could do this would be to have them statically in the map, so they're always in the same 3 rooms. This would be fine, but it doesn't lead to a particularly compelling gaming experience, because once you've solved the game, you can just go back and do it again, and then you can basically optimize how quickly and how few room changes you can do it in, but it's always going to be the same experience. So ideally, we want to randomize the key location on a per game basis. So we'll take a look at how I did that. What I chose to do was every layout has this K character in it. So that K is the position in the tile map of where a key would be if, for the game that we're playing, the key is in that room. So in room 0, the key would appear there up near the top somewhere. In room 1, it's going to be down the bottom, and so forth. All of these rooms have a K in them. So when we start a game and the front end requests a room, we're going to want to only render the K character if that room actually contains a key for that game. So we need two things here. We need something to randomize the selection of what room numbers it's in, and something to remember that, so that on a per game basis, we can either delete this K character from the map before sending it to the front end so it doesn't render, or keep it in there. So the way I'm going to do that is using a Redis set, and we'll take a look at that here in the API new game route. So if you're following along, you can get this in the file server.js. There's some preamble here, but basically whenever we create a new game, we're going to give it a game ID, and that's going to be the current timestamp. We're going to use that as part of the key name in Redis for game-specific keys. So we'll have a look at what this stream stuff is later, and we'll skip over it for now. What we need to do now is figure out where to put our keys. So the user needs 3 keys in order to escape. We need to place them somewhere randomly in the game. So the first thing we need to know to do that is how many rooms are in the map. Now, I could have hard-coded that. There's about 31 rooms in that JSON file. But we can ask Redis that question. So what we need to do is basically say to Redis, hey, RedisJSON, what's the length of the array at the key name that we've stored the rooms in? So Kaboom::rooms. And the JSON path to the array is dot, so the array in the root of the document. And that'll tell us how many rooms we have. We also want a key in Redis, so we need to make a key name for this specific game's key locations. So we're doing that with key locations, then that game ID, the timestamp that we created. So now we have these 2 bits of information, a key name and how many rooms. We need to pick 3 random rooms, and we don't want it to be the key to be in one room more than once. So it's got to be 3 different rooms. The way I'm going to do this is with a Redis set. So a property of a set is that you can't have identical values in it, so they get deduplicated. So if I added 1, 2, 2, 4, 6 into a set, I would have 1, 2, 4, 6. The duplicates will be removed. So we're going to use this property of sets here. So what I'm going to do is basically do a loop until we've put 3 distinct keys into a set. And how I'm going to do that is pick a random number between 0 and the number of rooms, so the array index for the room that's going to have the key in it. We're going to add that to a Redis set using the sadd command, and this set is game instance specific, so each different game will have a different set of where the keys hide. And then we're going to use the redis.scard, the set cardinality command, to ask Redis how big is that set now. And we're going to loop around that until we've got 3 things in the set. So if we generate the same random number twice in the first 3, Redis will deduplicate that for us. And then we've remembered where those rooms are, where those keys are, which rooms they're in for this specific game. Now, there's a chance that during the game, the user will just get bored, give up and not play anymore. In which case, we've created a per game key here. So there's a potential for us to keep creating those as new games are made and run out of memory in Redis. So we'll do some housekeeping and we'll just say we'll get rid of that after a day. So we use the Redis expire functionality. We'll also explicitly delete it when they successfully complete the maze, but this just covers the case where they abandon the game and give up. So at the point at which the user's starting the game, we remember what rooms the keys are in, and that's how we determine whether or not to render the key in that room, as we saw before. Players win the game by collecting all 3 keys and exiting via the special exit door in the room in which they started. One thing we want to be able to do is give them some sort of metric of how well they did, and for that we'll use Redis Streams. So here I have the route in the Express backend again for starting a new game. And whenever they start a new game, we have a game ID that we saw before, and that is the timestamp of the current moment in time. So we're going to use that, and we're going to use that for all keys that are game specific. So what we're going to do is track the player's movements around the rooms, and we're going to create something called a game moves key for that. So we're going to have moves, and then the game ID as the key name. And we're going to use a Redis stream for this. So every time they move from one room to another, we'll add another entry to the stream. And because we want to track the start of the game, they haven't moved from a room to a different room at the start of the game. So we're going to add another sort of event for that. and we'll just add a start event to the stream. So here I'm using xadd. The asterisk basically says, hey Redis, you create an ID for this stream this stream entry. All stream entries have to have an ID and they have to be greater than all previous IDs. So by default, Redis is going to use the current timestamp for this, which is exactly what we want. It's going to give us a timestamp sequence of events for the game, starting with this start event. And the data that we put in doesn't really matter. We might use it for analytics later, but really we're just capturing the events and the timestamps. And that's what this is doing for us. And again, the user might abandon the game, get bored of it before they finish it. And when they finish it, we'll clear up the game specific keys in Redis. But if they abandon, we won't have the opportunity to do that. So I'm expiring that key after a day as well. So this will naturally clear up and look after the memory usage in Redis. So when they start a game, we are adding an entry to the stream. Now, the other time that we need to add an entry is whenever they move. So whenever they get a new room. So there's a route here that gets that room information. You might remember we used it to get the map. And what we're also doing when we do that is we're adding another entry to the stream, and we're calling that a room entry. So we're just putting room entry and then the room number as the name value pair that goes in the stream entry. And again, we're using the asterisk, which basically says, Redis, you assign this a current timestamp as the stream entry ID, and we're putting it into the move stream for that game. So as the user moves around, we'll build up this stream of data about them. And then when they finish the game, we can use that stream to determine some metrics, and we'll look at that shortly. So going over to the game here, I have the game, and I'm going to actually also get Redis Insight. And let's put these side by side a moment. So make the game nice and small and just reload it. So that's good enough. There we go. And we can see at the minute, we only have this one key in here, Kaboom rooms. So if I go in here and start a game, what we can expect when I refresh the browser here in Insight is that we have some more keys now. So we have one where we've hidden the keys, and we have one for moves for this, this game. So this key here is a stream type. So when I click on it, it's going to ask me to go over to the streams view. Redis Insight has a specific view for streams. And what's really cool about this is it auto refreshes. So what we can see here, if I expand this out, is that it's going to refresh every 5,000 milliseconds. We'll cut that down a little bit to 2,000 because we're going to do some sort of live walk around the game here. And we'll see we've got two events in here already. We've got this one with this timestamp at 6:37:57, and that was a start event. And then we've got a room entry for 0 when we loaded the original room up. So as I walk around this map, what we should expect to happen is we are requesting rooms from the backend. And as we see there, a new entry appeared in the stream. Every time we do that, we're recording that user's entry into the room as a stream entry, and the stream keeps getting bigger here. And as you can see, they're all timestamped. So if I go through a random room, I get moved to a completely different room, and we're tracking all of this. So every time they move from one room to another, they get tracked, and we're storing information about them. So the two metrics that we want to use as part of our sort of end of game analysis, if you like, or how well did they do, let me just copy that key. We want to see how many times they changed room. So we can do that with the xlen command that gives us the number of entries in a stream. So in this case, they've done 7 of those so far. And we want to see how long the game was. So the way we determine how long the game was is we look at the timestamp for the earliest entry, timestamp for the latest entry, do the math to find the difference between them. And that's the number of seconds that the game was running. So once they're done with the game and successful, we can do that and work out how long they took. So we can say, you completed this puzzle in so many moves and so many seconds. So how do we get those stream entries? To get the first one, we're going to do xrange, the key name, and then we're going to do minus and plus, which are like special IDs in xrange. They're telling us that we want to do a range of entries in this stream from essentially one end to the other, so all of it, but we want to do count 1 and just say, give us the first one. So the one with the lowest timestamp. So that's our start event, and that's the timestamp where it started. It has a -0 in it because Redis is so fast that it can receive multiple stream entries for a stream in the same millisecond. So in the event of that, it would store the second one as -2, -3, and so on. We don't care about those. We're just going to parse those out when we do the math. So to get the other end of the stream, we use xrevRange to get the end, so reverse range. And again, we want that same key, and we want plus, minus, and count 1. So we're basically saying the identifiers are the other way around now. We're just basically saying, hey, look at the entire stream and give us the latest timestamp. So we can see there the last thing they did was a room entry into room 2, which was that room I randomly teleported into. And imagine that was the end of my game. I'd finished then, I collected the keys and escaped. We would do the math to get the time that the user's game ran for. And we can see some code for that inside here. So somewhere down here, we should have, here we go, an end game route. So if a specific game ends because they successfully escaped, they went through that special door with the right number of keys, then what we do is we run those commands, the xrange and the xrevrange, get the data back, pass it into integers, and do some math. And similarly, we also do a xlen command, which will give us the number of moves. And after that, we basically clean up. So at the end of the game, we would delete this stream key because we don't want to use any memory in Redis unnecessarily. And we'll also delete that game-specific key that looked at where the keys were stored for this game. So everything gets cleaned up. And if the user doesn't finish the game, then Redis has got our back because we set an expire on both of those keys, and they will just naturally get deleted over time. So we're not leaking memory in Redis. Hopefully you've enjoyed this rather unusual demonstration of Redis's capabilities. RedisJSON is a module for Redis that adds a JSON data type. It's really useful when you want to store complicated documents and retrieve them partially or in full using a JSON path-like syntax. If you're interested in Redis Streams, we have a course here at Redis University. RU202 is a complete course that discusses the Streams data type. And if you want to play with this yourself, go ahead and get the code from GitHub and follow along. The README is very comprehensive and you should be able to get up and running in no time. If you have a problem or you just want to chat with us, join us here on the Redis Discord. We'd love to see you there. Until next time, please like and subscribe, and I'll see you again. Thank you. With me, Simon Prickett.
And in the corner.